Question 9 in Chapter 13 asks you to draw the Fischer projection for each of the following dash-wedge structures. So I think it's clear why they call these dash-wedge structures. You have these dashes on top, and so I say these dashes, that's the dashes, and then the wedges are those solid bars, wedges. The dashes mean that you are, the bond is pointing away from you. And the wedges, the solid ones, mean that the bond is pointing towards you. Pointing toward you. If a bond is just a regular line, then it's in the plane of the page. So it's neither going away from you or going toward you. So those are the three ways you can draw bonds. Why would you ever use these two ways? We haven't seen them before in the course. You would draw bonds pointing away or going toward you in order to show whether the left or right-hand version of a chiral carbon. So that those three-dimensional bonds are useful in showing what type of hand you have in a chiral, for a chiral carbon. In a left-handed version, some things will be pointing towards you and others away. And in a right-handed version, the things pointing towards you or pointing away will be different. So, you usually have those when you have a chiral carbon. And those bonds are showing the three-dimensional orientation of those groups. Now, if you were to draw out these structures, you would see that it would take a lot of time. And if you're a chemist working with structures that have a lot of chiral carbons, then you would be doing this for a significant part of your day. Emil Fischer was a chemist who did a whole bunch of things, but one thing he did was work with a lot of carbohydrates and a lot of sugars. And sugars have so many chiral centers. Almost every carbon in the middle of a carbon chain on a sugar is a chiral center. So he was drawing a lot of molecules. It was taking him a lot of time, and he developed a shorthand way of drawing molecules that have a lot of chiral centers, specifically sugars most of the time. But really it's just anything that has a lot of chiral centers. In his type of drawing, which is called a Fischer projection, the vertical bonds are all assumed to be going away. Exactly how they're drawn here in A and B. The horizontal bonds are just assumed to be coming out at you. So these would all the vertical bonds are going away from you. The horizontal bonds would all be coming out at you. That's the implication. He would say, okay, anybody who sees my drawings will have to know this much. And this way he can draw really quick structures, like this one on the left, but communicate a lot of information, like the structure on the right. So, when you're trying to redraw the structures that they give you, all you have to do is draw the carbon on top, that group. Oops. Let me make this. Carbon on top. The carbon on the bottom, and in between, just draw a vertical line. And the assumption is that that vertical line is all going to be bonds that are going away from you. Then, for any carbon in the middle, draw a horizontal line. On the right we have bromine, on the left we have OH. And these two molecules are the same. The one on the left is the Fischer projection. And the Fischer projection just shows this three-dimensional arrangement of the bonds, and therefore the chirality, but in a very quick way. And so it's useful for molecules that have lots of chiral centers, like sugars. Let's try to draw a Fischer projection for this second one. Draw the carbon at the top with the functional group on it, there, that aldehyde. And now we'll draw the OH at the bottom, and just draw a vertical line. Any carbon you have in between, draw a horizontal line, and then just fill in. We have a bromine on the right and a chlorine on the left. And these two structures are the same exact structures. They give you the same information. The vertical lines are going away from you. The horizontal lines are coming out at you. How about this one at the bottom? So here, draw the carbon at the top, including the functional group. So here that's an aldehyde. Then we can draw that little group at the bottom, so CH2, CH3, and then draw a vertical line connecting them. That vertical line represents bonds going away from you. Now draw a horizontal line for any carbons in the middle. So we have this one carbon in the middle, and on the right of that we have an H, on the left we have an OH. Those bonds are coming out at us. That's what's assumed when you see a Fischer projection, or that's what's implied when you see a Fischer projection. And these two structures are the same structures. This one on the right, that was very quick to draw, still gives you all of the information that's contained on the left.